All right, we are going to talk about a little bit more, I guess, about reflection and refraction of light. So some of this will be a little bit of a review, but basically we're looking into how you actually see objects. So we talked a little bit about electromagnetic spectrum and how the different wavelengths are seen as different colors. But understand that objects must reflect light in order to be seen. So all those colors you see is actually the wavelength of light that the object is reflecting. Okay, all the rest of the wavelengths of the light the object is absorbing. And that really just depends on the chemical structure of what the object is made out of. But we can see objects in different ways. So there can be opaque objects. These are things that don't allow light to pass through and only absorbs and reflects. So that's anything you can't see through, okay? Anything you can't see through. So for example, this glasses case right here is opaque. I can't see through it. It only will absorb or reflect light. It doesn't allow any light to pass through it. Something that's translucent by comparison allows some light to pass through it, and that would be something like if you've ever seen wax paper. Okay, wax paper kind of is cloudy. You can see light when it comes through. Okay, so some light's able to pass through, but you can't see all the way through it. Okay, you can't see all the way through it. And then finally, there is transparency, or it's being transparent. This transmits almost all light. These are things that are see-through, like glass. They don't really absorb or reflect any wavelengths of light, which is why most of the time transparent things are clear. Okay, they don't absorb any light and they don't reflect off anything for us to see, and we can see through them, so they appear to be clear to us. So you should remember this, the law of reflection. So the review is that the angle of incidence, so in other words, the angle at which the light rays come in, they're going to be bounced or reflected off at the same angle if they're going to be reflected off. So there's regular reflection. This occurs on smooth surfaces like glass or like a table or something like that that is very smooth. So regular reflection occurs there. Example would be a mirror. And then there's diffuse reflection. This occurs on a rough surface like a rock or a wall. So any light that's reflected off a rock or a wall, we'll be able to see those little indentations because of this diffuse reflection. It won't appear smooth to us because the waves will be coming off at different frequencies depending on the texture of the surface. So if there's a lot of light rays or wavelengths bouncing off to us, we might see it and be getting more wavelengths. We might see it as darker or lighter, and that really allows us to determine the texture of what we're looking at. And then the refraction of light. So remember, the refraction of light occurs when waves of light pass from one medium to another and a light wave is bent or refracted. So this can include bent waves. This was a problem on the quiz. Bent waves. The index of refraction indicates how much a material reduces the speed of light. In other words, how much it's bent. The more light that's slowed, the greater the index of refraction. So when we look at the index of refraction, if it's a big number, or a bigger number I should say, that means more light is going to be bent. If it's a smaller number, it means only a little bit of light is going to be bent. When we're looking at prisms, okay, the prisms bend the light, like those little triangle prisms we worked with. Prisms bend the light, and while they're bending it, they're separating those wavelengths into different categories, allowing us to then see a rainbow as it comes out. Light refracted through air layers of different densities can result in mirages. So if you've ever heard of mirages, walking through the desert, all of a sudden you see what you think is water. This is when you get light refracting through layers of air of different densities, meaning some light waves are going to slow down and kind of bend a little bit, and that's kind of when you see those ripples on the horizon that sometimes look like water. That's because of light refraction. All right, and that is all for our review on reflection and refraction. Thank you.